Hi everyone, this is Purnima Mahalingam. In this video lecture series, next we are going to discuss about our review of induction motor. Okay, before going to induction motor, let's see. This is an induction motor. Basically, we know that induction motor is an AC motor, and we have this motor, and we have how many? This is three-phase motor. We have it AC motor. We have three-phase induction motor and single-phase induction motor, and just to remember, we can see the structure of DC motor. By the structures, we have the stator is outside the stationary parts, and the rotor is an inner part. And in animation, the red one the north pole, and the green is the south pole, and opposite red and green polarity. And opposite rotor reaches alignment, the brushes moves across the commutator, connects and energizes the next wind. In animations, the commutator contacts the nose and the brushes, and the yellow sparks, etc. So this we know just to remember. Now coming to AC machine, just like DC machine, AC machines also consist of uh, stator, stator and rotor. We can see this is stator part, stationary part. We have a rotor part. This is same like DC machines. Here we can see the stator. This we have an outer part within a stainless steel frame, and the inner part is in a steel punches and distributed phase winding in the slots of inner circumference of the laminations. The outer stationary parts we have these are the some of the construction things. We have what is constructed within silicon steel, and three-phase winding and the one phase shift of 120-degree phase shift, and three-phase supplies includes one rotating magnetic field. The air gap between the rotor is 0.4 millimeter to 4 millimeter and determines the power of the motors. This comes under a stator and rotor. We can see the rotor. Rotor, we have two types of rotor. One is slip ring type. Next one is squirrel cage type. And squirrel gauge type, we can see the bar type, and slip ring we have connected with all this connected with single points. We have two types of rotor, slip ring type and squirrel gauge type. And what is the fundamental principle of operation means generation of the rotating magnetic field. We know the generation of the rotating magnetic field. This causes the rotor to turn at a speed that depends upon the speed of a rotation in a magnetic field, the rotating speed. There we can see the rotating speed. The uniform rotating magnetic field is produced in the air gap between the rotor and the stator. The air gap between the rotor. So we have seen the air gap must be between 0.4 to 0.4 to 4 millimeter gap, air gap, and it's applied the stator by applying three-phase balance supply. This is the fundamental principle of operation of three-phase supply. And the stator, how we are supply is put the stator supporting with the winding A, B, and C, three-phase winding, and we have a 120-degree phase shift, and we can see with the star connection and delta connection how the waveforms goes. This is phase A, phase B, and phase C. This is phase A, phase B, and phase C. I can see A, phase B, and phase C. We can here we have one single phase A, and is shifted with 120-degree phase shift, phase A and phase B and phase C. In general, we are seeing that three phases. Here the synchronous speed is 120 divided by P into F. So 120, that is the phase angle, P is the number of poles, and F is the frequency. We can see how the frequency. Okay. For synchronous speed. The stator magnetic field rotates in AC machines, and the rotor can't catch up the stator field in a constant. So the speed of the rotation of the rotor will be depends upon the number of magnetic poles present in the stator and the rotor. And the magnetic of the torque produced is the function of angle between the stator and rotating magnetic field. The number of stator poles must be identical if the torque is to generate. Here we can see the flux density distribution, how the flux density is distributed. We can see in this picture how the flux density is distributed. Here comes small video about single phase induction motor.
Stator winding, which is stationary, it has got two parts. One main winding and or auxiliary. Auxiliary winding is placed perpendicular to the main winding. A capacitor is connected in auxiliary winding.
Here we have two windings, main winding, auxiliary winding. Here we can see so there is no current. So now the current flows through only the main winding, through the main winding. Here we have a fluctuation of magnetic field. Simple.
Inside such magnetic field. The rotor will keep rotating in the same direction.
So now it is rotating in same direction. Let's see. So we need two field, but we have only one field. So it is working. So by using double field revolving theory, we can add an auxiliary winding. Now it is rotating.
Electricity is induced. And the induction
Flux rotating. F1 is equal to F tau.
single phase induction such opposite, but we can somehow be rotating in the same direction. This is the way single phase induction moves. The big problem today, how to provide such an initiative, we will be able to start moving of main winding
Yeah, the
and
capacitor.
add enough
The capacitor is added.
magnetic field, which requires specific speed. Such magnetic field gives starting to the motor. The motor will self-start.
Self-start. Why?
Has attained a specific
So we know that single phase induction motor is not a self-starting induction motor. I hope today you'll be understanding what is single phase induction motor and how the single phase induction motor run and why it is not a self-starting motor and how the motor is started, these things. With another video, with another good topic, we can see in next class. Thank you.